Today I want to talk about 4.6, which is negative zero exponents. This is one of my favorite sections in this book. I enjoy working with exponents, and I know at times it can be confusing, but I think if we just learn some basics and get those basics down, we'll really see that they're not very hard at all. Okay, so but let's look at this. I looked at this in class, but let's do this again. We're going to evaluate 2 to the third. That's 2 times 2 times 2, which is 8. 2 to the second is just 2 times 2, which is 4. 2 to the first is just 2, which is obviously 2. Okay, so if I'm going up from 2 to 4, from 4 to 8, I'm actually multiplying by 2, because 2 to the fourth is going to be 16, and that's really 8 times 2. So if I'm going down, I'm actually dividing by 2, right? So 2 to the 0 power is equal to 2 divided by 2, which is 1, because I've got to keep with the pattern here. I'm dividing by 2. So that means anything, and let's get to our first rule, for any non-zero number x, x to the 0 is equal to 1. Any number to the 0 power is equal to 1. Any number, pi, to the 0 power is equal to 1. Okay, anything, and that's easy to remember. Okay, but let's keep going. 2 to the negative 1, well, I've got to stay with the pattern. Okay, so I've got to divide this by 2. Well, if I divide 1 by 2, I simply get 1 over 2. Keeping with the pattern, 2 to the negative 2, I divide 1/2 by 2, I get actually 1/4. But that can also be written as 1 over 2 squared, because 4 is 2 squared. Okay, so let's look and see if we can see something that might help us. Remember, this is 2 to the first, right? Now, we never write it, but we know it is. So 2 to the negative 1 is the same as 1 over 2 to the first. Notice here the change. The negative, the positive. Okay, negative 1 here, positive 1 here. What has changed? Only the position of this number or this power. It was in the numerator, because remember, any whole number can be written as a fraction with that whole number in the numerator and 1 in the denominator. Okay, but when we move it to the denominator, all of a sudden the negative 1 becomes positive 1. Same here. I've got negative 2, but once we move it from the numerator to the denominator, all of a sudden it becomes a positive 2. So when I take a number I take a power, any number with an exponent, and I move places with it, I change places with it, either from the bottom to the top of a fraction or from the top to the bottom, it changes the sign of the exponent. Okay, now I can't separate the number from the exponent. They all have to, it's a package deal. It all has to go together. But I can move it and I can change the sign of the exponent, which is going to help us greatly with this section. Okay, let's look at a few of these. 5 to the negative 2. Okay, now I want to write it using only positive exponents, so I just need to change the sign of the exponent. And remember, I said if we change positions with it, then it becomes a positive exponent. So it is in the numerator here. All I have to do is move it down to the denominator, and it becomes 5 squared. So it's 1 over 5 squared. The sign changes when I move it. Okay, now this 100,256 raised to the 0 power, that's easy. Anything raised to the 0 power is just 1. I like problems like that. Those are easy. Now this one, 3 has a positive exponent because it's 1. Okay, we don't see the exponent on 3. But x has a negative exponent. The 3 is fine. The x isn't. So we want to move the x. Okay, and I'm going to move the x to the bottom. I'm going to leave 3 on top. And so that becomes 3 over x3. Now I've got positive exponents. Okay. Here, what's the problem? The b negative 2 is the problem. a3 is fine. Leave a3 in the numerator. Move b to the denominator, and all of a sudden it becomes a positive exponent. That is a 2, by the way. Down here, I've got x2, y negative 2, z4. What's fine? The x2 and the z4 are fine. I can leave those alone. They stay in the numerator. But the y2 has to go to the denominator. Now it's a positive 2. Here, I've got 3, y squared, x negative 3. Well, the x negative 3 is the problem child here. Okay, so I've got 3y squared here. And I have to move x negative 3 to the bottom for bad behavior. Now he's getting a positive attitude. We've got a positive exponent. So negative exponent, move them down, make them positive. The rest, these have positive exponents. They're fine. 3 has an exponent of 1, y has an exponent of 2. We're good. Okay, now here, this is a little confusing almost. If we look at it closer, though, we'll see it's not very confusing at all. X to the 0 is really just 1. Well, what's 2 times 1? Well, it's really just 2. Okay, y negative 4 has to move to the bottom. It's got a negative exponent, so it becomes, I'm sorry, that shouldn't be a negative, but I wrote it as a negative, so it's y positive 4 on the bottom. Z2 stays on top. So we got 2Z2 over Y4. Let's look at some more. Now this says write the expression without using a fraction bar. If I don't want to use a fraction bar, that means I need to move the denominator to the top. So I have nothing but a 1 in the denominator. Then I can remove the fraction bar. So if I want to move 6 up to the top here, I have to change the exponent, the sign of the exponent. Well, there's really a 1 on 6. We don't see it, but we know it's there. So if I move it to the top, it becomes 6 to the negative 1. It changes signs. Any movement changes signs. Okay, this has an exponent of 1, but I want to move it to the top. So it becomes x to 11 to the negative 1. Okay, x6, we want to move it to the top up here. When I move it to the top, it changes the sign of the exponent. It becomes 2x negative 6. Okay, this one, move this to the top. That becomes x7 z negative 2. Okay, and this one, I want to move it to the top. I've got 3x squared and then y negative 4. Again, the movement causes a sign change of the exponent. Okay. Now let's work some of these. 3 to the negative 7 times 3 to the 11. Well, first, I need to see the instructions, and it says you basically use only positive exponents in your answer. So if we get an answer with negative exponents, we have to fix it. 3 to the negative 7 times 3 to the 11. Notice we're not multiplying the 3 times the 3 and getting a 9. That doesn't make sense. I add the exponents, okay? These are bases. They don't change. Negative 7, positive 11 gives me a positive 4, and I'm done. This exponent's good. 5 to the negative 8 times 5 to the negative 7. Well, I add negative 8 and negative 7. I get negative 15. But I have a problem. Got a negative exponent. Move it to the bottom. It becomes 1 over 5 to the 15th. Okay? Changes the sign. X negative 4 times x negative 1 becomes x negative 5. Remember, I'm not multiplying. I'm adding the exponents. Okay? Move it to the bottom. Becomes 1 over x5. Here, y negative 2 and y10 multiplied together. You add the exponents, it becomes y8. Exponent's fine. It's not negative. I'm good. Now here I'm subtracting exponents because I'm dividing. And the easy thing to do, well, to me it's an easy way of getting it correct every time, is you take the exponents to the side and you subtract them and you show the subtraction. Now you'll notice when I subtract, I've got a negative 3 and a negative 4, which is same sign. So same sign sum, I end up getting 2 to the negative 7, which is a problem because I've got a negative exponent, so I just move it to the bottom. It becomes 2 to the 7. 1 over 2 to the 7, excuse me. This one's a little tricky. Look, I've got a negative 8 on the bottom. So if I'm going to subtract the exponents, that becomes 2 minus negative 8. What happens to the two negatives? They become plus. 2 plus 8 is 10, so I get 7 to the 10th. Nothing wrong with this exponent. It's positive. Okay, look at the number part. I've got a 5 here, but I have nothing below here to reduce the 5. So I'm just going to write 5 in my answer. Okay, now I've got 3 and a negative 9. Well, 3 minus negative 9 becomes 3 plus 9. 9 plus 3 is 12. So I end up getting K 12. Okay, B negative 4 and B negative 6. Negative 4 minus negative 6. Got two pluses there. 6 and negative 4 give me 2. So that's B squared. One more here. I've got A3 over A negative 2. Let's do this to the side. 3 minus negative 2 becomes 5. That's A5. Then I've got negative 4 minus negative 6. That becomes a plus. That becomes 2, B2. Nothing wrong with these exponents. I'm through with my answer. Let's look at this word problem. I didn't get a chance to do this in class, but it has nothing to do with what we're doing today. It's just a word problem to look at. For babysitting, Nicole charges a flat fee of $3 plus $5 per hour. That's a rate. We see the word per. That's a rate. What is the rate multiplied by? Well, whatever this unit is right here. We got to find hours. Write an equation for the cost C after H hours. Well, there's our hours right there. H is hours. Okay, so the equation for the cost, we're just going to say that's C. Well, the cost equals what? Well, she charges a flat fee of $3. That's going to go into the cost every time, but it's only charged once, not over and over again, so it's just added in the cost. Now, I've got $5 per hour after H hours. That is a rate multiplied by hours. That is 5H. And that is a very simple linear equation set up from this. Okay, now what if she makes, how much money will she make if she babysits 5 hours? What we're going to do is plug 5 in for H and then find out what the cost is. So the cost is equal to 3 plus 5 times 5, okay, which is 25 plus 3, and that's going to equal 28. So she makes $28 after 5 hours of babysitting. Very simple linear equation to set up. And hopefully after seeing a few of those, you are already pros at this. And that's all for today.